Welcome to the walkthrough for Assignment 1B. The purpose of this assignment is to deepen your experience using Java's functional programming features and their integration with Java's parallel streams. In particular, in this assignment, you'll develop an app that uses Java parallel streams to obtain, transform, and store images. Like the first part of this assignment, the code you'll write here has a GUI, runs as an Android client app, and performs all image processing locally on the client device. Please use this GUI along with the unit tests discussed below to help evaluate and debug your solution. The following resources may be helpful in completing this assignment. Detailed overviews of the Java Parallel Streams framework are available in this YouTube playlist. Naturally, we'll cover this material in class, which will be available in my YouTube CS253 playlist here. The book Modern Java in Action is a great resource to learn how to program Java streams, as we've discussed before. Before you start the initial submission of Assignment 1B, you'll need to do the following. Update your implementation of Assignment 1A, taking into account our review comments, as well as the changes made to the specification of the sequential streams crawler skeleton to better reflect proper usage of Java Streams framework and functional programming. Please come to office hours or post questions on Piazza if you have any questions about your Assignment 1A solution and/or the specification revisions in the updated skeleton. The image crawler app is packaged as a project using Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 1B, however, you only have to be aware of the following directories. Image crawler crawlers, which contains the skeletons you need to fill in, as described below. Image crawler source test, which is a set of unit tests that exercise the features you're implementing and are used to evaluate whether you've correctly satisfied this assignment's requirements. An app source Android test, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 29, so you need to select an emulator that uses API greater than or equal to 29, though I recommend API 30. If you don't already have an Android emulator, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You need to modify several files containing the skeletal Java code by completing the to-do you fill in here tasks to provide a working solution. Do not change the overall structure of the skeleton, just fill in the to-do tasks, and don't delete the to-do tags. In particular, you'll need to finish implementing the following to-do tasks for this assignment in the image crawler crawlers folder. First, you'll need to implement the parallel streams crawler.java file, and you'll need to complete the to-do tasks in various methods to obtain, transform, and store images. This class uses Java parallel streams to perform an image crawl starting from a root URI. Depending on the parameters used to run the tests, images from HTML pages reachable from the root URI are either downloaded from a remote web server or read from the local file system, and the results are stored in the local file system on the Android device. You should first convert your sequential streams crawler class from Assignment 1A to reflect the updated specifications in the skeleton. Next, you should implement the parallel streams crawler class in Assignment 1B by making minuscule changes to the sequential version to use Java parallel streams. Please note that the sequential streams crawler class has changed in a number of ways, which we'll talk about when we get into the discussion of the skeletons in the next part of this video. In particular, there's a new method, and there's also new specifications of how you should implement the program to use functional programming and Java streams consistently from top to bottom. You should also update the student.kt file to complete the to-do tag, which sets the type set field to include just graduate or undergraduate, depending on which version of the assignment that you're actually implementing. Your solution should use no loops and no if-else statements in the assignment. Instead, use Java parallel stream, aggregate operations, and functional programming features. Of course, you should use sequential streams for the sequential stream crawler implementation. Your solution will be considered correct if it passes all the unit and instrumentation tests that we provide. Skeletal code for this assignment is available here in my GitHub repository. Now that you've set up your GitLab account, you can simply pull this skeleton code into your repository, read it carefully, and complete the to-do markers. The unit tests in the image crawler source test folder are provided to increase our confidence that your implementation is working as expected. Please use the Android Studio GUI to run the unit tests locally on your computer, as described at this link. As usual, testing only demonstrates the presence of bugs, but not their absence. So don't rely solely on the unit test to detect problems in your code. Assignment 1B is designed to deepen your experience developing apps using Java functional programming features and Java parallel streams without the need to create threads or to program the Java fork join framework directly. The skeletons and unit tests are extensive, though you don't need to understand them all to complete your solution. Please start early and ask questions in class, office hours, and on the Piazza discussion forum. So now that we've talked about the specification for assignment 1B, let's take a look at the skeletons. Keep in mind, if you go into the crawlers folder, that you can take a look at sequential loops crawler, which shows you a lot of the logic that you'll need to use, especially for the helper methods, things like web page crawler, get page, and get page elements, and things like that. There's also some other methods down here like create new cache item and apply transform. Keep those methods in mind because you will need to use them when you do the sequential streams crawler and the parallel streams crawler. But of course, those will have a different structure because you're going to be using sequential and parallel streams respectively. So with that in mind, let's now go take a look at sequential streams crawler. And so sequential streams crawler has been modified since assignment 1A for the better, hopefully. And what I've done here is updated the comments that you need to take into account when you implement the solution. So the first method you'll do is the perform crawl method. And this one is actually very, very, very similar, perhaps identical to what you did for assignment 1A. You'll create and use a Java sequential stream in order to use a factory method to create a one-element stream that just contains the page URI. And then you'll go ahead and use an intermediate operation to filter out the page URI if it exceeds the max depth or it's already been visited. That should look very familiar. You'll use another intermediate operation to recursively crawl all the images, or recursively crawl the hyperlinks, and then look at the images that are on the page and anything that's reachable from this page, and return the total number of processed images. And then you'll finally use a terminal operation to get the total number of processed images from the one element stream. So again, that should be pretty much what you had before. So just kind of cut and paste that and make sure you address my comments if there were anything left over. Let's go take a look next at crawl page. So crawl page is a bit different from what you had done before. It's done much more interestingly now. So this will also start out by using a sequential stream, and it'll basically use a factory method to create a one-element stream that contains just the page URI. That should be familiar by now. And then you'll go ahead and you'll use an intermediate operation to get the HTML page that's associated with that page URI. And that's where you need to go back and look at the sequential loops crawler to make sure you find the right method to call to get a page given a URI. There's a helper class and a helper method to do that. And then at that point, you need to filter out any missing null HTML pages. If you got a URI that was incorrect, you need to get rid of it at that point because you don't want to be processing nulls. And then you'll use another intermediate operation to call process page. We'll look at process page in a second. That's a new method that I added because it cleans up the code quite a bit. That will process the images that are encountered during the crawl. And we'll see that process page is where some parallel streams stuff will get done when we get to the parallel streams implementation. Right now we're just doing sequential streams, of course. And then the last part of this method will use a terminal operation to get the total number of processed images from the one element stream. And that should also look very familiar to you as well, because it's basically what you had done at the end of perform crawl. Here's the new method. This is called process page. And you can see process page uses a Java sequential stream in this implementation to download and process the images on this page via process image and recursively crawl any other hyperlinks that are accessible from this page via perform crawl. And then finally, it'll return a sum of all the images that are processed during this crawl or during the processing of the page. So here, basically, the steps you have to do, this again is similar to what you had done for assignment 1A, it just refactors the code to be a little cleaner and a bit more modular. And it also sets things up very nicely to be parallelized seamlessly in the next file, which is the parallel streams crawler. So what you'll do first is you'll get a list that contains all the images and page elements on the page. Once again, please go back and take a look at the sequential loops crawler to see how you do that. It's really straightforward. You did it for assignment 1A. You'll then convert that list that you get back into a sequential stream, just using good old .stream. And then you'll use a transforming operator, an intermediate operation that does transforming to basically map each web element, be it an image or a page, into a count of the images that are produced by either processing the image or by crawling the page. And again, that should look very familiar to assignment 1A that you did before. It's basically going to use the transforming intermediate operation that can be used to convert reference types to primitive types. And you'll do some calls there to perform crawl or process image and so on. And then the last thing you'll do is you'll sum all the results together. That also will look fairly similar to what you did in assignment 1A in this file, but it's been refactored to be a little cleaner, and it keeps your code a little bit more concise. The next method that you'll have to implement is process image, and this will use a Java sequential stream, and it will be basically applying transforms that have not already been applied and cached. So there'll be a method you have to call that you can find by looking at sequential streams crawler to tell you how to do that. So you'll have a little stream here that'll start out by emitting the URL using a factory method. So it'll be, again, a one-element stream. Then you'll go ahead and get or download the image from the given URL. And this, again, is something you can take a look at the sequential loops crawler to see kind of how to do that. Pretty straightforward. And then you'll filter out any null results that come back, just in case something went amiss. You can go ahead and ignore anything that's null. Then, once again, you'll apply an intermediate operation to transform the image and return a count of the number of transforms applied. And this, again, will call down to the next method we'll talk about here in a second, which is called transform image. And what you want to do is you want to get back essentially an int stream from that, and you'll then go ahead and sum the images that were processed by calling transform image. Remember, as we'll see in a moment, transform image will actually return you multiple results because it'll apply multiple transformations, which is important to understand. And then we have another kind of intermediate method, which for this particular assignment is just there as a placeholder. We'll do a lot more cool things with the next assignment. For right now, it basically just checks to see whether or not you want to run the transforms remotely or not. And in assignment 1B, you will run them locally. So it'll always go to the transform image locally branch of this ternary operator, this basically question mark colon operator. And in the next assignment, we'll have a transform image remote branch, which will use other stuff we'll start talking about next week. For right now, though, you just care about transform image locally. And what that does is that calls this little method here, and that will apply the crawler transforms on the image that was passed in as a parameter. And it'll basically return an int, not a stream. It returns a count that's left over from a previous implementation, a count of all the successfully transformed images. So basically what you'll do here in this particular method is you will once again create and use a Java sequential stream, and that will take the list of transforms. There's a variable called mTransforms, and it'll convert that into a stream of transforms. And then you'll go ahead and essentially attempt to create a new cache item for each image, filtering out any image that has already been locally cached. So that should give you a hint about what intermediate operation to use there. And then you will apply each transform to the original image to produce a transformed image. And after lots of thinking about that, we decided to split that up into two intermediate operations as opposed to joining them together with a conditional. So you'll first filter, and then you'll transform. So that should give you a hint about which methods to use there. And you'll call the apply transform method. And we'll talk about apply transform. Apply transform is basically a helper method that you can find if you peek around in the superclass for these classes. And it basically does the transforming of an image based on the transform that's passed in. You'll then go ahead and filter out any null images that weren't transformed. So if something comes back that's amiss, you'll ignore it. And then you'll count the number of non-null images that were transformed. So you'll get giving back an int here as the result for this. So that's basically the last method you'll fill out for this assignment. Then, of course, for the next assignment, which is assignment 2A, or maybe assignment 1C, depends on how we want to do it, there'll be another method called transform image remotely. But ignore that for now. It's not tested for. So that's basically the steps that you'll do for sequential streams crawler which again is just a slight variation on what you did for Sequential Streams Crawler in Assignment 1A, just refactored a little bit cleaner and using functional programming and streams from top to bottom. And the unit test should detect anything that migrates away from what we are looking for. And the other thing that we did is we added this process page method, which just makes things a little cleaner. Okay, so that's Sequential Streams Crawler for Assignment 1B. Let's now go take a look at the Parallel Streams Crawler. And what's really, really cool about this particular assignment, and the point I'm really trying to drive home, is if you do your design correctly, if you structure your code properly, you can make changes between sequential and parallel be absolutely minuscule. And that's precisely what we've managed to do here. By organizing the Sequential Streams Crawler in the way that we've done it, the Parallel Streams Crawler is basically cut and paste from the Sequential Streams Crawler, but replacing sequential streams with parallel streams. And that's really cool. And of course, the main point of this is once you get both these things working properly and they pass the tests, you can go into the instrumentation tests and run this stuff, and you'll be able to see that the parallel version is way, way faster if you're running on a multi-core machine. So the structure is essentially identical. Some parts of the code are identical, like perform crawl should be identical. When you get into crawl page, the interesting thing is that the crawl page implementation is also identical, so those things will be the same. And then when we get into process page, that's where we diverge ever so slightly. So as you can see, if you look really, really carefully at the specification for process page for parallel stream, really the only major difference here is that it says, after you get the list of the images and page links on a given page, it says, convert the list to a parallel stream. So now you're using parallel stream, not a sequential stream. And so that's one place where all of a sudden, boom, you've taken advantage of the underlying multi-cores, assuming you have them. And then if you look down further into process image, you'll see that that uses what appears to be a sequential stream. So that's going to be pretty much identical to the version you had before. And then when we take a look at transform image locally, then you'll see that that's where we have things be slightly different again. So once again, if you take a very, very close look, you'll see that the specification says, convert the list of transforms into a parallel stream as opposed to a sequential stream, and that'll run the transforms in parallel. So in essence, what's happening here is anywhere where we're working on groups of things, right? So here we're working on transforming one image into a group of transformed images. We're going to use a parallel stream in this implementation. Likewise, if you take a look here at process page, where we're going to basically get a list of all the images and the page links, we're going to go ahead and process the images and the page links in parallel, right? So wherever there's a grouping of things, rather than doing them all sequentially as we've done before, we're going to go ahead and do them in parallel. So that's the big win. That's why you get the massive speed up. But as you'll see when you do this, the code itself is largely unchanged other than going from sequential to parallel. So we're now in the Android Studio showing what your test should look like if you decide to run the test, or when you decide to run tests, because please run the unit test. So there's a couple different ways to do this. One way is to open up the Gradle tab, which you can see here, and go into the auto grader portion and then just run the unit tests. And if you do that, then everything should go ahead and build, and then it'll run a bunch of tests. And if all goes well, you should pass all the tests with flying colors. It takes a while to build the tests, so I went ahead and pre-ran those tests. But you can see that, surprise, surprise, my master version of this stuff passes the tests. I know that that's a great surprise to everybody. So that's one way to do things. There's another way to run the test too. The other way is to come in here into the left panel, and you click down to source, test, and then Java, and then you can go ahead and run the tests. And this is another way of doing it. There's some benefits to doing it this way. It's typically a little faster after you do it the first time. So as you can see here, the tests are kind of cranking away and compiling and building. And then if you run the test this way, you should be able to see that a bunch of the tests are going to be ignored, and the other tests will be run, and you can see here that we passed all the tests. So if you take a look up there, you can see 32 tests passed, 4 of them were ignored, and then here are just some results. You can pretty much ignore the results. But this will give you a good idea of how things work. And of course, if anything goes wrong, then you'll get little errors coming up there that'll tell you what's happening, and then you can begin the fun process of figuring out why your test didn't pass. This particular assignment will run tests that test both your sequential streams crawler implementation as well as your parallel streams crawler. And the tests are fairly sophisticated, so they'll find all kinds of interesting things. Tests are not foolproof, so as always, make sure that you use other means to make sure your code is correct. Those other means being like looking at the code, and then also, of course, submitting it for review, and I'll give you back feedback on your code so that you can take the feedback and integrate it. So there's just some things we can't easily test for, but we try to test for as much as we possibly can because it gives you faster feedback than having to wait to come to office hours and go, why is this not working? So it'll hopefully be relatively painless to do this.